So our steps for simplifying are factor the numerator and denominator. So before we didn't care what the numerator was when we were just finding NPVs because we didn't care, right? But if it says simplify, you have to go to the numerator and the denominator and see if you can take out GCFs or see if you can do difference of squares. If you can, you do to both, okay? Once you have both the numerator and the denominator simplified, you're going to state NPVs, and then if there's anything common to the top and the bottom, you can cancel them off. But you always have to state NPVs before you cancel. Okay? So if you've canceled it off and you state the non-permissible values after you cancel, that answer will be there. It's wrong. You have to state at any point in time if there was a non-permissible value. So, example 1, express the following rational expressions in simplified form stating the non-permissible values as restrictions. And can I take anything out of the top? In A. It's just a monomial, right? There's no plus or minus signs, correct? So what are they attached with? Multiplication. And if they're attached to multiplication, you can put them in their own brackets. So it's going to equal 12 and then x squared. She's moving with their walking. That's so weird. Okay, on the bottom you have a 2 and you have an x, and they're multiplied, so you can put them in their own brackets. Now before you simplify and cross off anything that's common, you have to state non-permissible values. So in the end, our x is going to cross off. We have one x down here and 2 up here, right? So our x is going to go away, but we always have to state non-permissible values before we cancel. So our non-permissible value here, our NPVs, does 2 get me a non-permissible value? No, it doesn't have a variable. And then we just have x can't equal 0. Bless you. Now, once we've stated our non-permissible values, we can cancel off. If there's anything in the top that matches anything in the bottom, we can cancel. So, in the bottom, we have 1x. What's x squared? X squared is just a fancy way of writing x times x, is it not? So instead of having the squared, we could just write it as x times x, could we not? And it's a 1-for-1 deal. If you have something on the numerator that matches something in the denominator, you can take 1 for 1. Okay? So this x can cross off that x. Now we have coefficients. We have a 12 and we have a 2. When numbers are by themselves, that's the only time that they don't have to match exactly in order to cancel them off. What could I take out of the 12 and the 2? A 2. And when you take them out, what are you doing? Dividing. So I'm dividing this one by 2. So it cancels off and it's a 1. Anytime these cancel off, these actually just turn into little 1s. Do you see how they're just 1s? And this 12 cancels off and becomes a 1, but what's left over? A 6. So we still have a 6 there. Because the whole 12 didn't go away, right? 12 divided by 2 is 6. 2 divided by 2 is 1. And you have to be able to divide it out of both. And the reason why that 2 goes away that you divide is you would pull out a 2 and you'd pull out a 2, and what would those 2's do? Cross off, right? So that's why they can go away. That's why you don't have to write the 2's that you canceled out, because you took it out of both the top and the bottom. Now, we're left with 6x on the top and a 1 on the bottom. If I have a 1 in the denominator, do I need to write it? If I have a 1 in the numerator, do I need to write it? Yes. So in the denominator, I don't. In the numerator, I do. And then I'm going to follow behind with x cannot equal 0. Now, if I stated non-permissible values after I canceled, I actually don't have a denominator. So you'd say there's no non-permissible values, and you'd be wrong. Okay? We always have to state non-permissible values before we cancel. So before you go to cancel, slap your hand and be like, did I state non-permissible values? If I did, move on. If I didn't, I have to. Okay? Right before you go to cancel. Okay, let's look at B. B is already nicely in factored form. Yeah? So I still have to state my non-permissible values, because I did step 1, factored form. It already is. Step 2, state non-permissible values. So my non-permissible values, my NPVs, are going to be a minus 7 cannot equal 0, and a plus 1 cannot equal 0. Add the 7. A cannot equal 7. Subtract 1. A cannot equal negative 1. So my NPVs are a cannot equal 7 or negative 1. Once I state non-permissible values, I can say, is there anything in the top that matches anything in the bottom? If you're on your phone, that's a problem. Put it away. Away. Okay, now, if there's plus or minus signs in between, we said those are attached. They're sewn together, correct? That's one object. So the only thing with a plus or minus sign that's going to cancel off is if it has an exact replica on the bottom. So are there any that match completely? The A plus ones. So this A plus 1 and this A plus 1 can cancel. Can this A and this A cancel? No. This A is sewn to the minus 7. This A is sewn to the minus 6. If those are human beings, you just decapitated both of them. You are just really mean. There's a lot of blood. It's really disgusting. Do not do that. Okay? They have to match in every single way if they're attached by plus or minus signs. So that's why if something's attached by a multiplication symbol, I put them in their own separate brackets. And if they're attached by plus or minus signs, I put them in their own separate brackets too. Then anything that matches completely can cancel. Okay? So what's left over? A minus 6 and A minus 7. Do they match in any way? A minus 6, A minus 7? It would be like saying that me and Mackenzie are the exact same. We're both human beings, but we're not the exact same, right? So you can't cross us off. You can't cross off our heads. That's even more bad. That's just disgusting. We're just dead. We don't want to be dead. We want to be here. So we are going to say A cannot equal 7 and negative 1. Now what happened if you stated the NPVs before you can, or after you canceled? You're just going to tell me that A can't equal what? Plus 7. Is that true? No. Okay. C. C has 8y plus 2 in the numerator and 8y in the denominator. 8y plus 2 in the numerator and 8y in the denominator. What could I do to the numerator? Anything? Nope. What could I take out of the numerator? This 8y plus 2 is attached, is it not? 8y plus 2 is attached. So could I cross this 8y off with this 8y? No. And this 8 and this y are attached by multiplication symbols, so they're technically separate. Okay? I could take a what out of the top. I just told you what it was, a 2. I could take a what out of the 2? Oh, a 2 out of the top. Okay. So, take a 2 out of the top, and I'm left with 4y. 8y divided by 2 is 4y. What's 2 divided by 2, guys? Plus 1. You cannot get rid of that. If you divide the same thing by the same thing, you are left with a plus 1 behind. Okay? It doesn't just go away. It's not 0. Like 7 divided by 7 is 1. 10 divided by 10 is 1. So 2 divided by 2 is 1. Okay? You have to have that plus 1 at the back. And then the 2 is in its own brackets because it's by itself. The 8's in its own brackets. The y is in its own brackets. If it's attached by multiplication symbols, it's in its own brackets. Okay? Does the 8 get me a non-permissible value, guys? No. Does the y? Yes. So what's my non-permissible value? Exactly. Y cannot equal 0. Okay. Once I say my non-permissible values, I can cancel off stuff that matches. So on the top, I have a 4y plus 1. They're attached, correct? The only way that 4y plus 1 is going away is if there is a 4y plus 1 in the denominator. Is there? No. That 4y plus 1 is staying for life. It's not going away because there's no match of it. So I know on the top, I for sure am going to be left with 4y plus 1 in the answer. I have to be. There's no match of it in the bottom. Now, some people try and cross this y off in the denominator with this y. Can you do that? No. 4y plus 1 is a one entity. You can't cross off parts of it. The only way you can cross it off is if you have a 4y plus 1 in the bottom. Sewn together, okay? The y has nothing matching it. It goes to the bottom. What about the 2 and the 8? What could you take out of both? 2. 2 divided by 2 is 1. 8 divided by 2 is 4. So I'm left with a 1 on the top. Do I have to write the 1 in front when it's a multiplication? No, but could you? Sure. And then a 4y. And we'll have y cannot equal 0. D. On the top, we have negative x plus 7. I can't take anything out, so I'm going to leave it as negative x plus 7. It equals the previous statement, so I'm going to put an equal sign. What's 49 minus x squared? Can I take out a GCF? No. What's the two options it could be? Difference of squares. So it is. Square root of 49 is 7. So that's going to go in the front of my bracket. Square root of x squared is x. So that's going to go at the back of my bracket. And what signs do I need? Plus and minus. So before you ever cancel, you have to state your non-permissible values. So my NPVs are x plus 7, or 7 plus x, cannot equal 0, and 7 minus x cannot equal 0. Subtract 7, x cannot equal negative 7, add x, 7 cannot equal x. So our NPVs are x cannot equal positive or negative 7. Now, remember they have to match in every single way. Do they have to be in the exact same order? No, but the signs in front of the things have to be the same, correct? So on the top, I have negative x, positive 7. Is there any term in the bottom that's negative x and positive 7? Yes, this one. So these cross off, and when they cancel, they become 1s. We agree? When anything cancels off, you're left with a 1. You're not left with a 0. You're left with a 1. So a lot of people will tell me the answer is 7 plus x. Is the answer 7 plus x? No, the answer is 1 over 7 plus x. What answer are they going to for sure have there? 7 plus x. Absolutely. So you're going to get 1 over 7 plus x. X cannot equal plus or minus 7. Okay? Try E and F. Think about GCFs and difference of squares. Remember? GCFs and difference of squares. Okay, so the first thing we do is we go to the top and to the bottom and we say GCF difference of squares, right? So in the top, can I take anything out? 4 and p. 12p squared divided by 4p is 3p. Minus 8 divided by 4 is negative 2. P divided by p cancels. And then the 4 and the p are attached by multiplication, so I'm going to put them in their own brackets. On the bottom, I have 6p cubed and minus 4p squared. So I could take out a 2 and a p squared. This equals this. I'm going to put an equal sign. 2p squared. When I take a 2p squared out of 6p cubed, I'm left with 3p. Minus 4p squared, take out a 2p squared, I'm left with 2. Now I know you get excited to see that these match and that they're going to go away, but remember we can't state non-permissible values until we stated, we can't cross off until we stated non-permissible values, right? So does the 2 get me a non-permissible value? No, the p squared is just p times p, so what is it going to be? 0. And then we have 3p minus 2 can't equal 0. Add the 2. 3p can't equal 2. Divide by 3. P can't equal 2/3. So we have 2 at non-permissible values. 2/3 and 0. Now, what matches? The 3p minus 2's match, and they match completely. If only the 3p's matched and the minus 2 didn't. What if one was a minus 2 and one was a plus 2? Could I cancel them off? Could I cancel off 3p's in front of them? No, they have to match completely, okay? And then I have a p squared and a p. This one p takes off one of these p's. And then 4 and 2, I can take a 2 out of. So 2 divided by 2 is 1. 4 divided by 2 is 2. So on the top, I'm left with 2. And on the bottom, I'm left with p. And then p cannot equal 0 or 2/3. On f, what could I take out of the numerator? A 3. And then I'm left with an equals 3. T squared minus 25. T plus 3, t minus 5. I'm not done. What's t squared minus 25? T plus 5, t minus 5. It's the difference of squares. So you're going to get 3, t plus 5, t minus 5. If nothing cancels when you think you're done simplifying, there's probably a catch. You probably missed something because something probably simplifies. Does it always? No, most of the time. Now I can cancel off the t minus 5, so I go ahead and do that. No, you have to do your MPVs first. So our MPVs, we have to state before we cancel. T plus 3 cannot equal 0. T minus 5 cannot equal 0. Subtract 3. T cannot equal negative 3. Add 5. Bless you. T cannot equal positive 5. Once we state our MPVs, now can we cancel? Yes, bless you. So the t minus 5's cancel. Can I cross this 3 in front off with the 3 with the t? No. Can I cross this t off with the t above it? No. T plus 5 is t plus 5. Is there a matched t plus 5 in the denominator? No, it's going nowhere. Is there a matched t plus 3 in the numerator? No, it's going nowhere. So the worst thing that people do is oversimplify. It's not often that they undersimplify, it's that they oversimplify. T cannot equal negative 3 and 5. Okay? Your turn. Try these ones out. Okay. So this one I have 18, and I have x to the 4, and they're multiplied, and it's a monomial, and there's nothing addition-wise or subtraction-wise, so they just go in their own brackets, right? Then on the bottom we have 36 and x to the 7. Now x to the 7 is just x times x times x times x times x times x times x, is it not? So all of those x's would get me the MPV x can't equal 0, correct? Do I have to state it 7 times though? No. So my only MPV is x cannot equal 0. Because x to the 7 is literally just x, 2, 3, 4, 5, 6, 7. So you'd have 7 MPVs that are x can't equal 0. You just don't list them 7 times. Okay? Now, what can I cross off? 4 of these x's can cross off 4 of these. So how many do I have left? 3. And where are they left in? In the bottom, right? They're left in the bottom. So just keep them there. Some people go 4 minus 7 is negative 3, negative 3 to the top, so then I move it to the bottom to make it positive. I'm like, that's a lot of work. Just cancel. Where it's left, it's left. I had 7 in the bottom, I had 4 in the top. All 4 in the top are gone, and I still have 3 in the bottom. Okay, in the denominator. 18 and 36, I can take out an 18. 18 divided by 18 is 1. 36 divided by 18 is 2. So I'm actually left with 1 times 1 in the top. What's 1 times 1? 1. It doesn't go away. and then 2x cubed in the denominator, and x can't equal 0 as my NPV. B, my numerator, I could take out a 3y. When I take a 3y out of 3y, I'm left with a 1. Minus 9y squared, take out a 3y, I'm left with a 3y. In the denominator, I have 6y cubed. The 6y cubed is multiplied together, correct? So I can put them in their own brackets. The 3 and the y can go in their own brackets because they're multiplied. The only NPV I get is y times y times y, which is just can equal 0. Once I state my NPVs, I can cross off anything that's common. I have a 1 minus 3y in the numerator. Do I have a 1 minus 3y in the denominator? No, that baby's staying for life. It's not going anywhere. What about the y and the y cubed? Can I take something out of those? 1y. And then this one I'm left with a 2. So I'm left with a y squared in the denominator. In the 3 and the 6, I can take out a 3. 3 divided by 3 is 1. 6 divided by 3 is 2. So I'm left with a 2y down here and a 1 up here. Do I need that 1 though? No. Okay, I have 3a cubed minus 3a squared. What could I take out? A 3a squared. If I take a 3a squared out of 3a cubed, I'm left with a. Minus 3a squared divided by 3a squared, I'm left with a 1. The bottom I can take out a negative 12, and I'm left with a minus 1. So I had to take out a negative 12. If I took out a positive 12, they wouldn't match. They'd be the wrong signs. So my NPVs are going to be a cannot equal 1. Now the a minus 1 and the a minus 1 can cancel because they match exactly. Had you taken out a positive 12, though, they wouldn't match exactly. The 3 and the a squared are in their own brackets, and so is the negative 12. Can I take anything out of those? What can I take out? A 3. 3 out of 3, 1. Negative 12 divided by 3, negative 4. So I'm actually left with a squared over negative 4. A cannot equal 1. So the first thing we always ask ourselves when it says simplify and we just have something over something, like just literally one rational, and this is a rational. A rational is when you have something as a variable over something as a variable, or at least the numerator or the denominator has a variable, okay? Mainly the denominator, a lot of the time. When you have a rational and it says just simplify, you have to see Gcf difference of squares, Gcf difference of squares. State NPVs, then cancel. 3 steps, okay? Gcf difference of squares, the numerator and denominator, NPVs, and then cancel. So your homework is page 329. Sorry, 229? No, I said 329. Numbers 2 to 8 and 13. There's quite a few, but the only way you get better at these is by practicing them. So you need to practice. 2 to 8 and 13 in your textbook.